All right, let's look at a couple other quadrilaterals. If you remember from our classification chart, underneath parallelograms, we had special types of parallelograms. We had 3 different types of parallelograms. We had a rhombus, a square, and a rectangle. So we're going to look at all 3 of those now. Now, because they're classified as parallelograms, that means they'll have all the properties a parallelogram will have, and they're special parallelograms, so they'll have even some more properties that parallelograms didn't. So that's where we're going to start our list. A parallelogram had both pairs of opposite sides are parallel. Well, a rectangle and a rhombus and a square all have those because they're all classified as parallelograms. Again, based on this idea here that they're underneath parallelogram in the family tree. A rhombus, a rectangle, and a square have all the same properties. So that means diagonals bisect each other? Yes. Rectangle, rhombus, square. Both pairs of opposite sides are congruent? Yes. It'll be true for all these special parallelograms. And so that's all the things that we can get from them being parallelograms. Now we've got to check some of the other properties. Now, exactly one pair of opposite sides are parallel. That still does not hold for any of these because that's saying it's kind of like, well, if we don't have the first one, right, if we don't have both pairs of opposite sides are parallel, then maybe we have at least one, like exactly one, not more than one. And so since we have both sets parallel, then it can't be, they can't have exactly one. Now we're just going to go through rectangle and check out the rest. So diagonals are perpendicular. Let's look at a rectangle and see if the diagonals are perpendicular. So for that one, we want to actually look at, sorry for that. We want to look at this guy. All right, so here is a picture of a rectangle, and I can drag the R around and move that rectangle. I can drag the E, right, and change it, and it's always a rectangle. Now, keep in mind the definition of a rectangle from the other day is all 4 right angles or 4 congruent angles. So no matter how I move this thing, right, the angles have to stay as right angles. Okay, and as I move it, we really want to pay attention to this angle in here where the diagonals meet. Let me see if I can make that a little larger so you can see it. All right, that guy in there which says it's 51.08 degrees, it never changes for this rectangle. Even if I made the sides a little thinner, right, if I do that, it's 17, right? So it's not, they're not perpendicular. Of course, I could make one particular rectangle where it goes to 90 degrees, somewhere around there, right? That's 90 degrees. But that's only one. There's all these other ones where it's a rectangle and it's not. So the 2 diagonals do not intersect at a 90-degree angle. So the diagonals are not perpendicular. So for rectangle, I do not fill in diagonals are perpendicular. Diagonals are congruent. Let's take a look at the diagonals if they are congruent. You can see here from this picture that all the diagonals, there's 3.19 units and 3.19 units to make up the entire length of one diagonal. So that diagonal, let's make it a better number. There we go, 3.2. So it's in total length, one diagonal from one corner to the other, one vertex to the other is going to be 6.4 units long. And the other diagonal is also 6.4 units long. So it looks like they are congruent, the diagonals. And if I move this rectangle around, the diagonals always seem to remain congruent. So that is, diagonals are congruent in a rectangle. That is a property of rectangles. Now we're going to move on to all sides are congruent. Well, when you look at this rectangle, clearly all the sides are not congruent. You can see that I can make 2 sides, the opposite sides really small, and then other opposite sides really long. So that proves that all sides are not congruent. Both pairs of opposite angles are congruent. So now we're getting into that opposite parts thing again. So let's look at another GeoGebra here for that guy. Let's see, which one do I like here? I think it is this one. Let's see how this looks. Yes, this will do. So you can see we have a parallelogram here, and I can move it around. We want the special parallelogram, like, see, I can move it. It's finally at one spot I can make it a rectangle. Maybe even a square. So I'll start it as a rectangle. We wanted to know about the opposite parts, right? So we know by definition that the opposite angles are, all the angles are 90 degrees. So obviously when I flip them around, they're all 90. So opposite angles are definitely congruent. If you look at the green 90, it ends up opposite, and the red 90 ends up opposite because there's this rotational symmetry in a rectangle. So opposite angles are congruent, of course, because they're all 90 degrees. So both pairs of opposite angles are congruent. True, they're all congruent. All sides are congruent. We said no. Exactly one pair of opposite angles are congruent. Again, that's saying, well, look, if we didn't get both, then do we have at least maybe one pair if we didn't have both? So once we check off both pairs, then we don't have to check the next one. That's for ones that don't have both pairs congruent. So all angles are congruent. That is true. So not only are both pairs congruent, but all the angles are congruent. So that's what we would say about a rectangle. Those are all the properties of a rectangle. Remember, the one that is its definition is all angles are congruent, or you could say all 90-degree angles, because it is a quadrilateral and they have to add to 360.